Okay, we are going to continue from where we stopped last time. Remember, we are discussing machine language instructions. And we said that these are instructions which the machine understands. They are usually zeros and ones. So we started discussing some of these. And you remember, the first one was register-to-register transfer, where we said that the register-to-register transfer, the opcode, or if we can remind ourselves, remember we said that every instruction has got an operation code, which is the instruction itself. And then it has got what we call the operands. That means either an address or the data which is required to complete the instruction. So the first example was the register-to-register transfer, where we said that you can move data from one register to another. Remember, we are using Intel 885 instructions or examples. And according to Intel 885, you remember, we saw that it has got 6 working registers: register B, register C, register D, register E, register H, and register L. And we said that there is also an instruction register, which we call the accumulator. So we said that data can be moved from any of these registers to another register. And the machine language for register-to-register transfer, we begin with the 01, that is the operation code. Then the 3 bits, the next 3 bits, those stand for the destination register. And then the remaining 3 bits, that is the code for the source register. So we discussed some examples. And then we also talked about the add contents of a register to the accumulator. So remember, with this one, we said that the add instruction, okay, just a moment. Just a moment. Hello.
Hello.
Yeah, you are. I'm sorry for that small interruption. So we were discussing the add contents of a register to the accumulator. And we said that there is always, we know the operation add needs 2 operands. You add something to something. You don't need only 1 operand, you need 2. And we said that the second operand has to be usually in the accumulator. So you just mention the source register, which will be added to the accumulator. So when I say, for example, add D, I mean that add what is in register D to what is in the accumulator. Add C, add what is in register C to what is in the accumulator, and so on. So we were discussing these instructions, and we had worked out some examples. Okay, so if we can remind ourselves a bit, Can someone tell me how I can add, let me say, what is in register B to what is in register A? Add what is in register B to what is in register A. Okay, are you working? Add what is in register B to what is in register A. Remember, if the code is for the registers, the code is for the registers we are given. Register B is 000, register C is 001, register D is 010, E is 011, and so on. So if I want to add what is in register B to the accumulator, can someone give me the code, sorry, the machine language code for that one? Hello? Hello?
Yes.
Are you working? I don't hear anybody giving me an answer. I'm worried. Or is there a question before we continue? Otherwise, if you don't respond, we are losing time. Hello? Someone is saying, I don't know how to do it, sir. Were you in the previous class? Otherwise, we can't keep going back and forth. Is anybody doing anything? I am saying the question is to add what is in register B to what is in register A. I want a machine language instruction for that. No? Rodin, that is not the answer. Seems like...
Sir, excuse me, sir. Excuse me, sir.
Please.
Yes, I was asking, are we supposed to first add what is in register B to the accumulator, and then we add what is in register A to the accumulator?
You see, do you see the format for adding on the screen?
Yes.
Okay. So we said that adding needs two registers.
Yes.
Right? And we said that one register is already known, it is the accumulator. You just mentioned the other register. So if I say add B, that is the same thing as saying add B to what is in the accumulator. That means add B to A. If I say add C, it means add what is in register C to what is in the accumulator. Because the accumulator is the default, you just mention only the source register. And the answer will be in the accumulator. And the format is that one there.
Okay, sir. Thank you.
Okay. Now, Rodin, Naguera, I think you are right. I think that is the answer.
Me too, I'm getting the same answer.
Okay. Someone is saying it would be better if I wrote on the whiteboard. Yes, I can write there, but I would prefer that you listen and follow. Okay, because writing, okay, can be done, but I would prefer that you listen and be attentive and follow. That one can be done later on. Okay, now, suppose I want to add what is in register B to what is in register C. Can someone tell me how we can do it? Suppose the question is add what is in register B to what is in register C. You got the question? Add what is in register B to what is in register C. No, that is not the answer. B. This time it is register B to register C. I'm afraid you people, you never revise. You have forgotten everything. Namale, I think you are right. It is not adding, because we said that if you are going to add, one of the operands has to be in the accumulator. So in this case, we are adding register B and C. None of these is in the accumulator. So we first move one of the operands to the accumulator. Then we can use the format for adding, and we mention the other register. So it is a two-step instruction. Otherwise, you need it. There are two instructions. The first one is moving one of the operands to the accumulator, and then you add the other one. Okay, that is right, Gloria. Then you will add C. I'm waiting for the answer. Hello? I said this instruction can be executed using two instructions. The first instruction is to move to the accumulator. You can move B or C, whichever. Then the second instruction is when you add. So it is not one machine language instruction. I think you are not right, Charlotte. The first instruction is not right. Come again, Solomon. I said, if you were here, if you were attending last time, we said the addition is commutative. It doesn't matter which is the A. If I say add the A to B, any of them can be a source. We said that adding, you just mention only one register. The other one is always register A. So when I say add the B, that means add the A to what is in register B. Okay, Rodney, I think you are right. Okay, that is how you do it. Because we said you first move what is in B to register A. So in such a case, we use the register transfer. The code for register transfer, the operation code is 01. Then you mention the destination register. We are going to take a B to A. That means the register A is the destination. The code for A is 111. And the B is the source because we are moving from B to A. So the first instruction of moving what is in register B to register A is 7801. That is the opcode. 111, that is the destination. And then is 000, that is the source. Then when you come to adding, here we are adding C. That means you are adding what is in register C to what is in register A. So the operation code for adding is 10000, and then you mention the register which you are adding to A. In this case, the register I'm adding to A is register C, which is 001. So that is the source register. Okay. Maybe another example. Can we add what is in register D to H? D to H. D to H. Okay, we are adding D to H. Gloria, it is not one step. We first D to H. Add what is in register D to what is in register H. I'm waiting for the answer, ladies and gentlemen. We are losing time. Okay, 70A, 84. Very good. Very good. Because we first move what is in D to A, that is 70A, and then we add what is in register H. Okay, that is very good. Now, suppose someone asks you to add, let me say B to D, and they put the answer in L. Add what is in register B to what is in register D, and then you put the answer in register L. B plus D equals L. That means take what is in register B, B add to D, and then the answer, put it in L. Add what is in register B to register D, and then put the answer into register L. Are you working? Hello? Hello?
Yes, we are here.
Okay. B plus D, and the answer is in the L. Hello? I don't hear anybody. You are not chatting, you are not asking a question. Where is the confusion? Hello? Yes, that is another step. 3 steps. 3 steps. Rodin, I think you are not right. You are first moving B to A, that is right. Then you add the D. The code for D is 010. The code for D is 010. And then the instruction to add, I think you can see the screen. The instruction to add is 100000. Then the destination register. Then the last step is okay. Storm, I think moving to L is not right. Otherwise, adding B to D, that is okay, but moving it to L is not right. Charlotte, I think you have got it. Okay, Gloria, you are right. Okay. So that is, so we first move what is in D to A. Then we first move B to A. Then we add D. And then we move. This last step, Gloria, is not okay. We are moving. This time the destination is register L. The destination is register L. We are moving because when we add, the answer is in the accumulator. When we add, the answer is in the accumulator. So if we are going to put the answer in register L, that means we are moving from the accumulator to register L. L is the destination, the accumulator this time is the source. Gloria, can you do it, please? The last step, A to L. Hello, are you there?
Yes, sir.
Yeah, no, it is not 7C. The code for moving is 01. Then you mention the destination register, because we are saying the destination register is register L. And the code for L is 101. And the source is the accumulator, because we are moving from the accumulator. So the accumulator is 111. So you have 01, 101, 111, which becomes, I think, 6F. Okay. Okay, so let us continue. But I request that you keep on revising these things. So let us continue. The next machine language is to subtract. Now you note the operation code for subtracting, sorry, the format for subtracting. The code for subtracting is 100010, then SSS, which means that we are subtracting from the accumulator. So when I say, for example, subtract D, I mean A subtract D. When I say subtract C, I mean A subtract C. So you just mention the source register. So can someone write for me a code to subtract? What is it? To subtract, let me say C from what is in the accumulator. C from what is in the accumulator. Can someone write me a code for that? C subtract C. That means subtract what is in the accumulator from register C. The answer is usually in the accumulator.
I beg your pardon, sir.
I'm saying subtract is what is C, what is in register C from what is in the accumulator. Yes, you are right. It is 91. Very good. Okay, so it is 91. Then suppose someone asked, said, subtract what is the register B from C. B subtract C. If you write B subtract C, how would you do that? B subtract C. B subtract C. Are you there? B subtract C. A lot of silence, please. Can I hear from someone? Okay, that is right. Okay, so like we did in adding, you first put B into the accumulator, and then you subtract C. Okay, you are good. That is right. 78 and then 91. Now, suppose I said someone just says something like, let me say E equals D subtract C. E is equal to D subtract C. Someone who says that EDC, E, D, and C are Intel 8085 registers, and he wants you to solve that. E equals D subtract C. In other words, subtract C from what is in register D, and then they want the answer in register E. E is equal to D subtract C. I hope you are working. You are there? The last step is not okay. The first two are okay. The last step, we are moving now what is in the accumulator to register E. Because when we subtract, the answer is in the accumulator. But if we want to put the answer into register E is the destination, and the accumulator is the source. Okay, very good. So that is right. Okay, that is also right. Very good. Okay, thank you very much. So we can move on. We can move on to explore more machine language instructions. Okay. Now, we have what we call transferring immediate data to a register. Immediate data is just data which is not anywhere. For example, someone can say put 5 into register C. So 5 is the immediate data because it is available immediately. You are not taking it from memory. You are not taking it from a register. It is just available. So someone can say put, let me say 5 into register C, put 5 into register L, put 10 into register H, something like that, okay? Now, when you try to examine such an instruction, I think it has got like 3 parts. There is an instruction, there is a part, which is the opcode, which tells us to put data into a register, okay? To put data into a register, so that is the operation code. Then we have to mention the number we are putting into a register, and then we have to mention the register itself where we are putting data. So if I say put or add immediate data or put, just move, we usually use the word move, okay? Move 5 to register H. So you realize that we have got, the instruction is broken down into 3 parts. There is a move, then I have to mention the data itself which I am moving, which is the 5, and then I have to mention the register where I am moving the data. So that particular instruction has got 3 parts. So that is the format for transferring immediate data to a register. It has got 2 bytes. It is a 2-byte instruction. In the first byte, the first 2 bits, and then the last 3 bits, that is the operation code. So you begin with the 00, then you mention the register where you are putting the data, and then you end with the 010. Then in the second byte, you put the immediate data. Everything has to be in binary, or after writing in binary, then you can write in hexadecimal. So it has got 3 parts. It has got the operation code, which according to the format is the first 2 bits and the last 3 bits, 00 and 010. Then somewhere in the middle, the DDD, that stands for the register where we are putting the data. And then we mention the data itself into the second byte. So that is the immediate data. So suppose I want to put 7 into register C, and someone write for me a machine language instruction to transfer 7 to register C. 7 to register C. Seven into register C. 7 into register C. So C is the destination register, and the 7 is the immediate data. Okay, that is right. But the best way to express it is you write 0A, then 07 below it. So 0A, then on the second line, you write 07, just like it has been given there. The first byte on top, then the second byte at the bottom. So that is inputting a 7 into register D. Suppose I want to put 13 into register H. Suppose I want to put a number 13 into register H. 13 into register H. I want to put 13 into register H. And I write a machine language instruction for that. Very good. Very good. 2, 2, and then 0D. That is nice. Okay. So we can go on to another instruction. Okay. Do you hear me now? Hello?
Yes, we can hear you.
Okay.
Yeah.
Okay, please. So, well, what is being, do you see my screen?
Yes.
Okay, can you tell me what that instruction is doing?
You are transferring 12 to register A.
Okay, so we are transferring 12 to register A because the destination register is 111. We know that is the code for register A. And then the second byte has got 000, 110, 110 is a 12. So we are moving 12 to register A. Very good. Okay. Now, adding immediate data to a register. So someone can say, add 5 to what is in register A. Add 12 to what is in register A. Add 8 to what is in register A. So that one also has got 2 bytes. We have the data which we are adding to register A, and then the operation code. The whole of the first byte is the operation code. We don't mention register A, we just mention the immediate data. So the first byte is the whole of the first byte is the add A, add it register A. Now, what am I adding it register A? I just mentioned the immediate data. Okay. So can someone add, let me say 13 to register A? Add 13 to register A. Add 13 to register A. The answer is always in the accumulator. Add 13 to what is in register A. Okay. Charlotte, that is right. That is right. Because we have 2 bytes. The first byte is the opcode. That means adding it register A. So that is given by C6. And then the second byte, we are mentioning the immediate data. 0D is the 13. Okay. So suppose someone says D plus 5 equals E. Suppose someone gives you that instruction, meaning that D and E, assuming that D and E are Intel 885 registers, and it says D plus 5 equals E. In other words, add what is in register D, add a 5 to what is in register D, and put the answer into register E. Add a 5 to what is in register D, and put the answer into register E. Can we do that? D plus 5 equals E, meaning that add 5 to what is in register D and put the answer into register E. Okay. 5 plus D equals E. Hello? Not exactly. Can someone tell me, just tell me how we are going to do that? Rodin, that is not correct either. Can someone tell me how we can do that? The steps you need to follow. Hello? Can someone just tell me how we can do that so that maybe I can explain from there? Charlotte, okay? So you are saying we added data. We don't add the data to A, we move to A. We move what is in D to A, we don't add. We add what is in A to 5. The adding is adding, but if you want to first put what is in the accumulator, you move to A. So you will have to move D to A, then add a 5, and then move what is in the accumulator to the destination register, which is register E. Is that okay? Okay, can we do it then? Can I have the code? Because the addition is done in the accumulator. Addition is done in the accumulator. So when you say D plus 5, it means you have to move D to the accumulator first. Then you add the immediate data 5, and then you move the answer to register E, the destination. D to A, no, that is not right. A is the destination. When you are moving D to A, D to A is the destination, D is the source. Okay, so that is D to A. Then you add 5 to what is in A now. And then you put the answer into register E. Ladies and gentlemen, you are very quiet. I don't see any action going on, and I don't hear anybody talking or asking. Okay, that is very correct. 7A, C6, 0505F. Very good. So Pamela, can you tell me where you are lost so that I can repeat? Kindly let me know where you are lost. Don't tell me from the beginning. Hello? Can someone let me know where you want me to repeat so that we move together? At the end of this, you will be required to write a machine language instruction program. So someone will be giving you a program to write. Okay, I'm really lost also, because if you are saying a whole thing, that means that you want me to go back and explain, revise the registers, we revise what your computer is. I'm really lost. I'm also lost. Because if we have been together and I've been, I think, going slowly, I think you could stop me and I explain. But when you say, which steps now? Okay. Someone is saying that I repeat from subtracting. I'm sorry, I'm not going as far back as that, because you could have told me then. Okay. So let me repeat this one. The last thing we did, we have D plus 5 equals E. D plus 5 equals E. Okay, so in other words, you can say that add the 5 to what is in register D and put the answer into register E. Add the 5 to what is in register D and you put the answer into register E. Now, we have got we have so far seen 2 formats for adding. One format is adding what is the accumulator to another register. And then the second format, we have seen how we add immediate data to the accumulator. Now, this instruction we are talking about is the adding immediate data to the accumulator, because we have immediate data, which is a 5. But we are required to add it to register D. The format says register A. So the first step is to move D to A. We move D to A. Okay, so we use the register transfer. The register transfer, the code you begin with is 01. Then you mention the destination register. The destination register in this case is register A because we are moving D to A. So A is a 111. And then the source register is register D. The code for D is 010. So when you convert that to machine language instruction, you get 7A. So 7A is moving register D to A. Then the next step is to add, because now we know what was in D is now in A. So now we can add the immediate data 5. And what you see on the screen is the format for adding immediate data to A. So the first byte is adding it to A. Then the second byte is mentioning the immediate data. So the first byte is a C6. Immediate data is a 5. Okay. So that one, we are adding 5 to what is in register A. And we said that the answer stays in the accumulator. The answer stays in register A. Then we have to move what is in register A, that means our answer, to register E, because the answer is required in register E. So this time we do a register transfer from A to E. E is the destination, A is the source. So you have a 01. Okay, the destination is register E. Register E is 0111, 011, and then the source register is the A, 111. So that gives us 5F. Okay, is it clear now?
Yeah, it's clear.
Okay, please. So let us continue with the more instructions. As usual, I am requesting for your maximum attention. Then subtract immediate data from a register. Okay. Subtract immediate data from the accumulator, from register A. So I can say subtract 5 from A, subtract 12 from A, subtract whichever number from A. We usually subtract from A. Okay. Now, suppose I give you this. I said D plus C, subtract 14 equals B. Can you write that? D plus C, subtract 14 equals B. In other words, add what is in register D to what is in register C, then subtract 14 and put the answer into register B. D plus C, subtract 14 equals B. Philemon, there is no destination register here. This instruction here is not the destination register. Okay, this instruction, we don't have a destination register, we don't have a source register. We are just subtracting what is immediate data from register A. Subtracting from A is given in the first byte. So the second byte, you just mention what is being subtracted from register A. The whole of the first byte means subtractive immediate data from A, subtract from A. That is, we are not giving the code for A. Okay, we don't give the code for A. You look at the format. The format says subtract immediate data from register A. So you just supply the immediate data. What is in red is what you just supply. You have missed some steps. Charlotte, the second instruction I think is not very correct. We said we are adding D plus C. You look at the second instruction. Otherwise, 7A is okay. I don't agree with 87. D6 is okay. 0E is okay. 47 is okay. Alex, the second step is not right. It is not 91. Okay, very good. Charlotte, you've got it. 70A, 81, D6, 0E, 47. If I can explain, the first step is to move what is in register D to A. Move what is in register D to A, that is the first step. So 01 is move. The destination is register A, which is 111. And the source register is D, which is 010. So 01111, 010, that gives us 7A. Then we add the C. That means we add what is in register A to C. We use the format for adding. Okay. So the format for adding, you remember, is 1000. Then you mention the source register. So 1000, then you mention register C, which gives us 81. Okay, so we have finished the adding what is in register D and C, and the answer is in the accumulator. Then we subtract 14. Subtracting is a 2-byte instruction. Okay, So that one is a D6. That is the byte you see up. D6 is subtract from the accumulator. And then 0E is a 14. Okay. Then we move what is in the accumulator to register B. 01 is the opcode for moving. We are moving it to register B. The destination is 000, and then the source is 111. So you get that series of instructions. Charlotte, that is fine. Thank you. So can we move on? Hello? Hello? Okay. So the next example is
Yes,
a
you
load.
can continue, sir.
Okay. So the second example is loading the accumulator from memory. Okay. Now I want your attention. I want your attention here. Now, if we are going to move data, remember, whenever we are going to perform an arithmetic operation, information is moved from memory. Instructions and the data, they move from memory and they are brought to the CPU for processing, because the storage is in memory, but the processing is done in the CPU. Now, it means that if data is in memory and the instructions are in memory, they need to be moved to the CPU when the processing is going to happen. Now, remember we said that whenever information is moved from memory, it is put into the instruction register. We said the instruction register is the register which receives the instructions from memory. So it does not receive only instructions, but also the data. So whatever comes from memory goes to register to the instruction register. And remember, we said that in the case of Intel 885, the instruction register is the accumulator. So whenever I want to move data from memory to the CPU, we put it into the accumulator. Now, like we know, memory has got very many memory locations. Okay, so if we are moving a certain piece of data from memory, we have to mention the address of that particular memory location. Okay, and then we put the data, we put that data into the accumulator. So we usually give the address of a particular memory location from where we want to get data from. So we don't mention the accumulator from, because that is a default. Whatever comes from memory goes to the accumulator. So what we need to do is just to mention the address of the memory location where we are moving the data from. Okay, so this one is a 3-byte instruction. The first byte is giving the instruction to put data from memory or move data from memory and they put it into the accumulator. So we usually call that one to load. Whenever you move data from memory and you bring it to the CPU, we call it loading. Or putting data into a register, we call it loading that register. So we load the accumulator because it is the one which receives the information from memory. So we load the accumulator and then we mention from which memory location. So we load the accumulator from a given memory location. That means whatever in that particular memory location is put into the accumulator. So this one is, it has got 2 parts. There is a part for the opcode which says load the accumulator. Or in other words, you can say move data from memory to the accumulator. And then the operand is the address of the particular memory location, because every data is in a particular memory location. So we have to mention the address of a particular memory location. Now, if you can remember, we said that the address of the Intel 8085 is 16 bits. Because you remember we said that the stacker pointer is a 16 bits. Stacker pointer, you remember it is the address, which is, it stores the address which is on top of the stack. So whenever we talk about the address, those are 16 bits. Remember we said the program counter is a register which stores the address of the next instruction. So the address of the Intel 8085 is 16 bits. So it means that if we are going to mention the opcode, which like you can see is 80 bits, and the address is taking 16 bits, which is 2 bytes, it means that loading the accumulator from memory is a 3-byte instruction. The first byte means loading the accumulator, and then the next 2 bytes, that is the address from where we are going to get data to be put into the accumulator. Okay. Now, these are 2 bytes. Now, if we have got 16 bytes, if we have got 16 bits, so that those are 2 bytes. Now we can break them into 2 parts. Okay. If you can listen carefully, if we have got 16 bits and you break it into 2, you have 1/2, which is 80 bits, and then another half, which is 80 bits. Is that right? Now the second half, this is the lower part of the address, the one which is on your right. So if you can imagine that you have got 16 bits and you break them into 288, okay? The first part on your left, that is, we call that one the higher part of the address, or the upper part. And then the last 8 bits, that is the lower part. Now, when we are writing a machine language instruction, okay, we mention the lower part first and then the upper part. So we use this format. First, you mention the opcode, then you mention the lower part of the address and then the upper part of the address. Okay. So if I can give an example, suppose I have got an address, which is, let me say, 856D. 856D. Now, suppose these are hexadecimal digits. So if 856D, if these are hexadecimal digits, you remember every hexadecimal digit is 4 bits. It means I have got 16 bits, which is the address. So 856D, if that is the address, if you break it down into 2, 85 is the upper part and the 6D is the what? The lower part. So if I want to move to load the accumulator from memory location 856D, I will write the opcode 00111010, which I think is 3A. That is the opcode. Then I mention the lower part of the address, which is 6D. And then I mention the upper part of the address, which is 85. Okay. Am I clear?
Yes, teacher.
I beg your pardon.
Okay. Let me, can I request for your attention? I'm saying that sometimes, or in a number of times, when we are taking data from memory to the CPU, okay, data from memory to the CPU is received by the accumulator. Okay? because the processing is done in the CPU. So it means that whenever you have data to process, it has to be moved from memory to the CPU in order to be processed. Now I'm saying that whatever comes from memory goes to the accumulator. Okay. Now I have to mention where the data is in the memory, because the memory has got so many memory locations. Now, the data you want to put into the CPU for processing, you need to mention its address. Now, I said that the address for the Intel 8085 is 16 bits. Now, if 16 bits, those are 2 bytes. So if we have got 2 bytes and you break down those 2 bytes like into 2 parts, there is what you call the upper part and then the lower part. So I gave an example that if you can write, let me say 856D, 856D, so those are 16 bits, because if these are hexadecimal digits, each digit is 8 bits. So if I have 4 hexadecimal digits, those are 16 bits. Now, when you break those ones into 2, you have 85 is the upper part and 6D is the lower part. So if I want to put what is in that particular memory location into the accumulator, I mentioned the operation code, which is 3A, 00111010 is the operation code. It is 3A. Then I mentioned the lower part of the address, which is 6D. And then I mentioned the upper part of the address, which is 85. So that 3-byte instruction is moving whatever is in the memory location 856D, and it is putting it into the accumulator. Is that okay?
Yes, sir.
Okay, so here we are saying that this instruction moves contents of a memory location whose address is specified in those 2 bytes into the accumulator. Okay. Okay, now let me give you, let us have an example. Suppose I want to move, someone can give you, for example, a problem and it says x plus 5. Can you write that? X plus 5, let me say, says that is equal to b. X plus 5, that is equal to b. Now it says that x is a memory location. X is an address of a memory location. Now, if the address of x, let us assume that it is 3F8C. 3F8C. So this is the memory location, which is the x. And someone asks you to write a machine language program or instruction which will add x plus 5 equals b. Okay. Now, if you are going to do that, it means that you have to move what is in memory location x and you bring it into the accumulator, because that is where addition is done. Now you add the 5, immediate data 5 to what is in the accumulator, and then you put the answer into register B. Okay. So the first instruction is to move what is in the memory location X to register A, the accumulator. So it means that in this case, we use the format which is moving data from memory to the accumulator. So this instruction here. So can someone write that? Maybe someone can volunteer to do that. Can you try that one? Can you try that one? moving, sorry, someone says X plus 5, and you put the answer into register B. And I have told you the steps. Yeah? The address of X is given, it is 3F80C. So we put X into the accumulator. In other words, we load the accumulator from memory location X. Then we add immediate data 5. The answer stays in the accumulator, and then we move what is in the accumulator to register B. Can you write those machine language instructions, please? Okay, so that is like the first there you have moved X to the accumulator. Then you are going to add the to add the 5. Add immediate data 5. And then you will have to move what is in the accumulator to register B. So you continue. Gloria, you continue. Okay, I think you are right. Adding immediate data is C605. Okay, then you move what is in the accumulator to register B. Thank you very much, Charlotte. Okay, is it clear with the others?
Yes.
Okay. Okay, so the opposite of loading the accumulator is storing from the accumulator. You remember we said that loading, we are taking data from a given memory location and we are putting it into the accumulator. Now storing, we are doing the opposite, because sometimes after processing, you need to put data into memory after processing it. So sometimes after processing, you need to store, we call that one storing, to put the data into memory. Okay, so we call that one storing. Okay. Alex, you beg your pardon on adding C, X to 5. We said you first put whatever is in memory location X into the accumulator. Whatever is in memory location X, you put it into the accumulator first. Okay, so you use this instruction, load the accumulator. Load the accumulator. Okay, so loading the accumulator is 3A. And I told you that the address of X is 3F8C. I told you that the address of X is 3F8C. So the lower part of the address is 8C. The upper part is 3F. And loading the accumulator is 3A. So that is why we have 3A. Then 8C is the lower part, then 3F is the upper part. Okay, so that one puts whatever is in the memory location X to the accumulator. Then we add the immediate data 5. We use the format for adding immediate data. The format for adding immediate data, you remember, it is C6, and then we mention the immediate data. C6, and then you mention the immediate data. So 6, the immediate data is 5. So whenever we add, the answer is in the accumulator. So we have to move what is in the accumulator to B. That is 0, 1. The destination is register B, which is 0, 0, 0. And then 1, 1, 1 is the source, which is register A. So you get that code, which is the machine language instruction. So is it okay, Alex, now? For 7 is moving what is in the accumulator to B. Moving, this is register transfer. We are moving what is in the, because whenever we add, the answer is in the accumulator. But if they want the answer into register B, we move what is in the accumulator to register B. Register to register transfer, we begin with a 0, 1. Now the destination register is register B, which is 0, 0, 0. And the source register in this case is the accumulator, which is 1, 1, 1. So that gives us a 4, 7. Okay? Okay. So I was explaining the formats are usually given, ladies and gentlemen. We usually give you the formats, but what we don't give are the addresses of the registers. So the code is for the registers, those ones you should know. But the format are always given. The formats are usually given. You don't have to cram them. Okay. So I was explaining the opposite of loading is storing. That means after working into the CPU, you can put your answer into memory. You can store it into memory. Now, again, it is the same thing like a loading. We have the first opcode, which means store, and then the address where we are going to store. The memory location where we are going to put whatever we want to store. So in this case, again, you mentioned the lower part of the address where you are storing, and then the upper part of the address where we are storing. Okay, so let me give you an example. Sorry, a simple question. Suppose I say X plus X plus 7 equals Y. X plus 7 equals Y. Okay. Now, X is a memory location. Let us assume that the address of X is AB5F, and the address of Y is BD26. Okay. Can I repeat? The problem is X plus 7 equals Y. Now, X and Y are memory locations. Now, I'm saying that the address of X is AB5F, and the address of Y is BD26. Can you do this, please? Can you write machine code for that instruction? X plus 7 equals Y. I think this one is it shouldn't take you time. This is not 3A, Alex. Alex, 3A is okay, 5F is okay, AB is okay, C6, but the other one, storing, the code for storing is not 3A. Can you look at it again? The code for storing is not 3A. Okay, okay. Okay, the code for storing is 3.2. It is not 3A. The code for loading the accumulator is 3A. Storing from the accumulator to memory is 3.2. Okay, thank you very much. Thank you very much. Okay, so I beg that we stop here today. Now there is a request I am making. I'm not going to be around tomorrow and Friday. I won't be able to access my machine unless very late in the evening. I don't know whether that is okay with you, but I think it may not be possible. So it can be either Saturday to make up for that lecture, or we find some other day next week. So I will wait for your class rep to let me know. So we can have it on Monday to make up for the lecture we are going to miss on Thursday. Is it Thursday or Friday? Well, whatever. But I'm not available on Thursday and Friday. So either we make it on Saturday or sometime on Monday. So I will be waiting for the class rep to let me know. And then I'm also requesting the class rep for the evening group to let me know if you are attending these lectures for the day group. I would be happy if I was to be informed that you are attending. Otherwise, I don't want people to tell me that I didn't teach them. So I want confirmation that you are attending with the day group, so that will make me happy. And then the class rep can let me know when we are meeting again, either Saturday or sometime on Monday. Okay, so let us stop here, ladies and gentlemen. Someone is asking me to, I think these slides are already on Mwere. I think they are there. Someone is saying, but things are not easy for us. I am here to help. So you can call me, you can text me. I can do anything. I can do anything. So if the notes are not yet available, I think I will have them there. Okay. Okay. Have a nice day. Evening. Immaculate Nabunya. What is wrong with the evening?
I'm saying it's not so easy for us, though we are trying to attend.
Okay, so I don't know.
Hello, sir.
I don't
We
know.
try, but
Okay. So let the class rep let me know. Otherwise, if you can't make it, but I said the evening group, if you can't make it during the day with the day group, then I can teach you separately, but on condition that you raise a number. You can't teach one or two people, CCI. Okay? See if you can raise a number, then we can have separate classes.
all right, sir.
Okay. So have a good day.
Good
All right,
day
thanks.
too.